Like many other scientific discoveries, the determination of the speed of light was serendipitous in nature. It was during the 1670s when the Danish astronomer Olaf Ремер was studying Jupiter's moon Io that he noticed something a little odd. Ремер had been studying Io for some time in hopes of trying to map out an accurate orbital period for the moon. Ремер noticed that at times Io was either late or early to appear compared to standard predictions. Having timed this phenomenon over the course of a few years, Ремер noticed that the interval between successive eclipses for Io became steadily shorter as Earth moved closer to Jupiter and vice versa. Therefore, he determined light speed to be finite. Ремер knew that if Io appeared at a different time based on the position of the Earth in relation to Jupiter, then light would have to have a finite speed in order to demonstrate those delays and advances. If light speed were infinite, then there would be no discrepancy in Io's eclipses, and it would appear regularly without any inconsistency. Knowing that light has a finite speed, Ремер set out to measure exactly what that speed is. Ремer began by determining 2 points during the year, 6 months apart, as points in Earth's orbit when Earth is the farthest and closest it can be in relation to Jupiter. Ремer chose these points based on his previous observations of the appearance of Io. He found that when Earth was closest to Jupiter, Io eclipsed 11 minutes early. Similarly, he found that Io eclipsed 11 minutes later than predicted when Earth was farthest away from Jupiter. With that, Ремer calculated the speed of light using the formula d equals r times t, where distance equals rate multiplied by time. Solving for r, or rate, the real equation to solve for becomes r equals d divided by t, where distance is divided by time. In Remer's case, d is the diameter of Earth's orbit, and t is the time it takes light to travel that distance, which was determined to be 22 minutes. In fact, it was Remer's colleague Christian Huygens who made the initial calculation. Regardless, the end result turned out to be a speed of approximately 220,000 kilometers per second, about 26% lower than the actual speed of light. More importantly, however, was the fact that Ремер had just succeeded in providing the first quantitative measurement for the speed of light. Remer's newly calculated speed of light was not very widely accepted at first. It took almost 50 years for the scientific community to accept Remer's claim. For the longest time, most scientists, including Remer's own superior, Giovanni Cassini, had accepted the speed of light to be infinite. It was believed that light moved without delay and that it could traverse any distance instantly, with the distance from Jupiter to Earth being no exception. Cassini even went so far as to challenge Remer's claim and to attempt to outpredict Ремер, if you will. Cassini and Ремер both set out predictions as to when Io would eclipse one night, Remer's prediction being exactly 10 minutes after Cassini's. Cassini, negligent of Remer's discovery, turned out to be wrong, and Ремер was exactly right. Still, Cassini and other non-believers ignored the error and narrow-mindedly returned to their false notions. The speed of light was later integrated into Einstein's theory of special relativity, as a constant by which all things can be related to. Einstein also utilized the speed of light as the fundamental link for his combination of time and space dimensions, as a result, establishing a space-time continuum. Thus, Remer's once ridiculed discovery became the basis for physics as we know it.